Okay, everybody can hear me? Yeah, welcome to my talk about API development in Spring Boot and Kotlin. In this talk, I want to show you a little bit how we at OpenResearch develop APIs or software in general for backend systems. And first of all, I want to explain a little bit who is OpenResearch, what's the company. The company was founded in 2009 and grew constantly. At the moment, we are 32 employees in 3 different countries. It was founded in Vienna, where we still have our one office. And in 2016, we also came to Pristina, where we have an office with about 20 people already. And this year, we also started remote development in Croatia, so we are still expanding. Our main stack is that we do mobile, web, backend, and DevOps. And in different programming languages, you see the list is quite long. Our main stack is focused on iOS, Android, Java, Kotlin, JavaScript, Python. And since 2019, and especially this year, we also started Kotlin development, which will be the main focus in on this talk. I also listed some clients of us, but I think maybe you know some of those, but a lot of those are from Austria or Netherlands or Germany. A few words about myself. I started at OpenResearch in 2017 as CTO. I'm a big open source enthusiast and started developing about 1996. Yeah, I was quite young back then. And I'm a big Java fan since 2004. So it's a little bit discrepancy that I talk about Kotlin now as a Java fan, but I will explain you why I become a Kotlin fan now. I love framework development. I'm also a Java trainer. And next to the job, I'm also a diving instructor and motorcyclist. If you're looking for me, I put some links on the slides where you can find me online. So, first of all, I want to give you a short introduction to the timeline, how this whole Kotlin topic came into OpenResearch. In 2009, we started with PHP and Ruby development, and Java was used for Android because it was the default language there, and PHP and Ruby was just in our expertise. Then in 2016, we started to implement first backend applications, also based on Java, but already based on Spring Boot. So this was our first contact point with Spring Boot, and we still love it, we still use it. We'll talk about this a little bit later. In 2019, Kotlin was introduced by Google as the main programming language for Android applications. This was also the point in time where we first got in touch with Kotlin and implemented our first applications with it. The next year, 2020, so start of COVID, we also started implementing first backend applications with Python. Actually, to be honest, we were not very happy with Python, so we were looking for something else again. Of course, we still were on the Java road. But in 2021, with a big project in Austria, we started to work with first Kotlin prototype. And now, actually, I'm very happy that we have made that decision, because we made quite good progress, and I found out that something like code review and stuff in this direction is really, really much faster if you go with a much more concise programming language like Kotlin. Next to Kotlin, we also started .NET, but this would be another topic. So first of all, a few words about Spring Boot and why we at OpenResearch still love Spring Boot. So first of all, it helps you to auto-configure a production-ready Spring application. You don't have to fiddle around with all these configuration files. Maybe in the audience we have somebody who worked or still works with Java Enterprise systems. Then actually you should be still used to your XML configuration files. And in Spring Boot, I don't need a single XML configuration file if I don't want to. Of course, it's open to you, but you don't need to. So you're avoiding a lot of boilerplate code, and as already said, the XML. If I compare it, for example, to a Wildfly application server, also the whole handling is much easier, because I don't have to configure, I don't know, modules or create or insert modules into the application server, and then I have to enable them. In Spring Boot, I just add plugins, configure them with a single configuration file. I don't know if you have, who has used Spring Boot before in the audience? Hands up. Okay, so at least a few. So there is one single configuration file called application YAML or properties. There you can place your whole application configuration, and you don't need to fiddle around with all the XML files inside of the application container. So in my head, it's a big benefit to do it like that. Another big point is that Spring Boot supports us to build a 12-factor application. Actually, I don't really want to explain to you what the 12-factor application is, because I saw it in so many talks, and I would just ask you, go to the 12factor.net homepage, just read the 12 factors, then you would immediately know what I mean. Another big point for Spring Boot is they have built-in test support. So I don't have to make up any test framework myself. I can bring up the application with all dependencies if I want to. I can do unit testing, integration testing without an extra effort that I maybe would have to invest myself as a company, or maybe even bring in other companies. And the big plus is that since Spring Boot 2, which came out about 2 years ago, also has support for Kotlin by default. So VMware decided, so in the end, Spring Foundation, which is owned by VMware, decided to bring Kotlin as a first citizen programming language into the Spring environment. Of course, that's a big plus in my head. Java, so the pros on this side, why we also decided to use Java back then, is that it's, what did I start with? Yeah, of course, it's the main language of Spring Boot back then. And it's very widely spread. So wherever you go into big companies, I don't know, think about banks, insurance, everybody is using Java. And I would say they will continue to use Java for quite some years. I don't think they would go that way that we just do. So that's something, at least I don't think that will happen very soon. Another big point is tool support. If you think about Java or Kotlin, there are companies like JetBrains, which are the inventors of Kotlin even. So they, of course, have proper integration into their IntelliJ IDE. I don't know, I haven't tried Eclipse for quite some years, but I would guess also Eclipse has support for it already. Big point, Java is object-oriented and has real multi-threading support. Last year in our project with Python, we learned the hard way that multi-threading support can be very important if you have to be fast, and Python didn't offer that. So this was not the go-to language for us. There are also countless libraries for Java, so whatever problem you want to solve, you can be sure somebody already solved your problem and maybe even provided a library somewhere in the Maven repositories which are online and freely available. So goes in a little bit in the direction, don't reinvent the wheel. Also, Java is backwards compatible since Java version 1 until, I think, still with version 17 now. You can just run your application that you wrote 10 years ago with the latest version of Java. I'm not talking about external libraries or something like this, that's another topic. I already said that it was the default language for Android, so now it changed. And Java is still one of the top languages in the TOBE index, which is kind of based on search requests on Google. And everybody tells me Java is simple. But then you have to ask, what background do you have? Especially a C programmer will tell you, yeah, of course it's Java simple, because you don't have to do memory management. You have the garbage collector, you have a lot of stuff in your hand that just makes your life much easier than we had back 20 years ago. But in the end, I always come back to the same sentence. I tried to solve my problem in Java, now I have a problem factory. So whenever you see a big program, or if you see enterprise software, and maybe you get an introduction, you see hundreds of classes and different patterns, so a lot of stuff is in there. And Java is not a language where you can do a lot with a few lines of code. There's also always a lot of boilerplate code, which just makes your code much longer than it could be. And back to this Tiobe index, I just took a screenshot from it was the 14th of October. It was the third language on the list, so it was very popular for a long time. So maybe you ask yourself, but if you're so happy with Java and everybody's using it, why do you go away from Java? So as a first point I want to bring, there's a trend going away from this programming language. And I highlighted the green line from the Tiobe index, which just shows you how popular Java was over the years. I don't know if you can read it on the back, but on the left side there's 2002, and it stretches until 2020 or 21 something on the right. And I tried to place this dashed line in there, which at least I tried to average the green line somehow. There you can see more and more people are going away from Java. So what I want to say, we are not the only ones. Also, other companies are looking for alternatives for Java. So what are the caveats or cons from our perspective? In my head, Java is very verbose. So you can do everything, but you have to use a lot of lines of code to do the same what you can do maybe in 1 or 2 lines in another language. So, of course, if you have to use a lot of lines, code readability just goes down. So if you think about code review sessions with a partner in your team, the more you have to read, the longer it will take. One big point, maybe that's not so true at the moment, but if you think about the Java release cycle back before Java 8, this was completely unpredictable. It was more like, yeah, it's done when it's done. So I still remember the Java 8 release, which was a really big and long-awaited release for Java. And at the moment, the new release cycle is more a little bit, every half year you get a new release. And actually every 4 or 5 years you will get an LTS version. But if you think about the LTS version, the last one was Java 11. That's already quite a few years ago. And the next one, which just released, was Java 17 now. But, of course, all the libraries also have to adapt to the next release. The next release, 17, will be supported by Spring Boot 3. I just heard on the Spring 1 conference, beginning of September, that the Spring Foundation is planning to have Spring Boot 3 out there in the market end of Q4 2022. So it's still not something you will be very fast if you want to update to the latest versions. Actually, I don't think you can read what I have in my black box there. Can someone read it? Yeah? Okay. So actually, I just wanted to make an example what happens if you run that code. In the first line, I define a variable and set it to null. In the next line, I try to, I think, lowercase the same variable, but without any checks or whatever. So what will happen? Any ideas? Null pointer exception, exactly. That's, in my head, one of the biggest problems in Java. Whenever you run an application, there are null pointer exceptions everywhere. In every bigger application, you always, if you check the logs, there is one null pointer after the other. And that's a big problem Kotlin solved, for example. Yeah? And if those errors happen in your application, a lot of developers tend to do something like this. So I don't want to show an error exception message to any end user, for example. So what they do, they just make a try catch block. Catch block is empty. So when I see code like this in a review session, I always think about a sentence a senior dev in my past gave me on the way. And this was, don't eat exceptions. And actually, I still always have to think about this picture when I see code like I just showed you before. Maybe I can make a picture in your head as well. If you see code, empty catch blocks, just think about this sentence. So what's the advantages of Kotlin, or why we switched to it? First of all, there is Java compatibility. So we can still use all the frameworks we were used to. We still have the Java environment in our background. We can still run our application on JDK 11. as I said before, we can't switch until the libraries come up to the latest LTS version. So another cool thing is Java and Kotlin can coexist in the same application. Actually, I would have prepared also a live demo for some live coding, but actually I can't sit somewhere here and it's not my notebook. So I have to improvise a little bit. So one big plus on our side is we didn't have to switch anything except the programming language. And if you think about it, that, for example, you have a lot of Java developers, and as a business guy, you think, yeah, but do I really want to invest that 20 people will learn a new programming language now? I can give you on the way that for a good Java dev, the difference is so little that this will maybe take 2, 3, 4 days, and then he will be kind of used to these differences between Java and Kotlin. We made that change, and no single developer also who never saw Kotlin before had any problem switching to it. I don't know if there are a lot of Java devs in the audience, but one big thing is there's no Lombok support. There was no Lombok support, or at least you don't have the same features available in your Kotlin application, but they started to have their own Lombok version for Kotlin. But there is no builder annotation, for example. I'm a big fan of it, but it's still missing. There's a vote out there from the developers. So if you want the builder annotation in there, you have to upvote it. Cool feature I found very handy was, especially if you want to get used to write Kotlin code as a Java dev, was that there is automatic translation from Java to Kotlin in IntelliJ. So if you, for example, copy-paste Java code into your Kotlin file, they will ask you, okay, do you want to auto-translate your Java code to Kotlin? And the outcome was actually very good all the time. So, of course, you have to review it and maybe tweak a little bit because you're coming from Java and you're not using the features that Kotlin gives you. But on the other side, it's much faster than just writing everything again and doing it manually. Okay, so one big plus, as I already said, null safety. It's a similar example I had before. That's just a small piece of Java code, and you will find something like this. I mean, that's just a short example, but you will find such methods everywhere. You get an argument, then you just call like to lowercase or is blank or something like this on your string, for example. And then you see, okay, we have a null pointer exception again. Of course, there are solutions for it, but let's have a look how we can do this in Kotlin. In Kotlin, to make an argument for a method nullable, first of all, I have to tell Kotlin, okay, this argument can be nullable, because if I don't have this question mark next to string, if I skip that, then I tell Kotlin, okay, this argument can't be null. If I put it, then I tell him, yeah, okay, you can place null, but then you have to handle it properly. Because if you check the next line, I don't think you can see it, but under the dot, there is even a compile error. So you can't compile it unless you handle that this is null. So of course there is a way to tell Kotlin, but I know that this is not null. So the wrong solution would be to just place these two exclamation marks. So this would mean to Kotlin, yeah, I know that this could be null, but I just tell you it's not. So in the outcome, this would be the same as just running the Java code that you saw before, and you have your null pointer exception again. So how can we solve this? Just not allow null as a parameter, for example. So on the left, same method, same outcome, but in this case, I just skipped this question mark and told Kotlin, okay, please, the argument can't be null. So I don't have to handle it anymore. So it's a one-liner. Let's compare it to the right version, which is the Java version. If you see, I have an if then else. First I check if it's not null, then do the print line. But now I have an else clause. What are you doing there? That's up to the developer, right? So what's the typical solution for a lot of developers? Just throw an exception. Throw or return null, even worse. So throw an illegal argument exception, for example. And then what's the outcome of this? Think about it. Whoever calls your method will be the guy who needs to check what happens to your code. So what he should do with this exceptional case. So the exception is thrown, somebody has to catch it. And if you think about what the Kotlin code does, it just does kind of the same, but it's not afterwards it happens. So in this case, it just prevents you from sending null to the method at all. So the user of the method has to decide what should happen with null. So the outcome is the same, but nobody can forget to handle the exception. And just count the lines, of course, the code is much easier to read and much shorter. So another point, this null safety, it's not just for arguments of methods or whatever. So you can also use this for methods, for example. So if you check, well, I can't really see that, there's get corrected name as a method. And for whatever reason, I just return null. But I also do to lowercase in Kotlin. So in this case, in Java, if you would do the same, you would have your null pointer exception again. But in this case, I tell Kotlin, okay, if you return null, don't execute whatever is right of this method. So the outcome would be name was set to null. Maybe that's not what you want. Maybe you have to add some extra handling for this. But in the end, at least you don't have your null pointer exception again. So, of course, if I have shorter code, I also have better readability. I just made a really easy example how to make a value object, and I'm talking about language features and not something added on top like Lombok or something like that. So that's the easiest solution for the value object in Java. It's just, I need a class holding a name. So if I want to do the same in Kotlin, I just have to write this single line. Class, Kotlin, value in this case, value, name, string. And this braces, what you see there is already the constructor. And the value is also not changeable, so it's exactly the same code. Okay. Another thing you can't do in Java, which I found very handy when I saw it the first time, was that you can extend basic types with extension functions. So if you ever thought about, for example, in old Java versions, there was no isBlank method. So you always had to do your if clause and do it yourself. In the latest version there is, but if, for example, you want something like camel to snake case on your strings, you can't just say extend string and add this method somehow. But in Kotlin, I even posted the code for this at the bottom. Maybe it's not so easy, but it's possible. And now I would have a method camel to snake case on every string I put in my application. One warning to this, please don't overdo it. Don't solve all your problems with extension functions. This could really mess up your application. Yeah, that's one of my best my beloved topics, to be honest, because the compiler always tells me, yeah, you forgot your semicolon on line 15. Every C programmer, I think, can remember the same. Yeah, please place your semicolon at the end of this line. And I always thought, why can't you place it yourself? In this case, in Kotlin, I don't have to do it anymore because there is no semicolon at the end of the lines. Just call me lazy, but for me, this is a big plus. So also, let's come to a little bit to business view, why we decided to use Kotlin. And one of the biggest points for me was it's a very shallow risk if you just switch from the same environment and just place, in my head, easier language on top and compile to the same bytecode that you would get with your old application in Java. And of course, if you have shorter code, talked about it before, then you would also see it in your review sessions. And if your review sessions or your reviewers have to read less code, they will also spend less time in your sessions. And overall, you will also just spend less money on all these topics. Flat learning curve, as discussed before, it was not hard to learn it. And, of course, one big thing is Kotlin is used for Android development, and we also use it for backend development. So in theory, I could just ask an Android developer, please jump over and help out in the backend. It's the same language. Maybe he has to learn a few frameworks, but in the end, I just bring together the whole team, and not everybody has to learn, maybe who just learned Kotlin for Android, then has to learn something like Python or whatever. Another big thing is that also big companies decided to use Kotlin. So if you think about it, Google decided, okay, we use it as our default language for Android. So there is support from big companies. As I said, Spring Foundation, VMware also decided to support it because Spring Boot officially has Kotlin support. So, of course, everybody knows, every dev knows that Google is known to change opinions. But in my head, even if they would throw out Kotlin, there would be a path where to go. So that's also not a blocker on the road. And another important point is how often do you write code compared to how often you read it. So it goes in the same direction that readability and the length will be much shorter. Readability will be better and length will be shorter. Because if I have to read the left side, for example, I use the same example we had before. I have to read all these lines, I have to understand what the code is doing, and on the right side it's just a single line. And if you think about onboarding into a new project, for example, so you're the new guy, you have to go into the team, there is, let's say, 500,000 lines of code and you should read it. Of course, it's much easier for you if the code looks something like on the right, then you have to deal with the left side. Okay, now I have to improvise because I don't have a laptop in front of me. Actually, I wanted to show you a little bit how we started our applications, or how a typical API would look like. So actually, nobody has a laptop, so actually you would find the whole application online. It's on GitHub. It's just the same link 3 times, whatever you prefer. Yeah, actually that's for later. So, thanks to God, I was prepared for it. First of all, I want to talk about contract first versus code first. Our approach is that we decided to go contract first. So, who has ever heard about Swagger or OpenAPI? Okay, everybody knows what it is, not a lot. So what you do with OpenAPI is just specify how your API looks. You define all requests, you define all the request bodies, you define all the results, all the models. And what we do with this document is we generate Java code out of it. And there you see that we combine Java with Kotlin. Because I checked the Kotlin generator and I was not really happy with it. So I decided, okay, why not go with the Java version? That's the better one. So in this case, I generate the Java code based on the OpenAPI model. In my example, I used Maven. Yeah? How many minutes? 10 minutes? 5, okay. Can do that. So in my example online, I decided to go the Maven way. So you see at the bottom which Maven plugin I'm using. And outcome is that we are using this generated model for everything. So, that's unreadable. Okay, so on the left side, you see all this boilerplate code where you have to define, okay, this is a get, that's the path, and I don't know, that's the params, that's the name of the param in the URL. And on the right side, you see how we start to implement. Yeah? So we are using the delegate pattern, which is already included in the code generator. So all we have to do is extend an interface, and then we can immediately start mapping our business logic with the HTTP transport layer. So actually for me, this is a lot easier to handle because I don't have to fiddle around. Okay, I need proper documentation for the client. If you ask me for a documentation, I will just generate an HTML file for you based on our Open API specification. Another thing we are using is spin mapping. In this case, as I have to be shorter, we are using mapstruct or dozer. So if you ever heard about it, it's an easy tool if you have two classes with similar types or names. It's just a mapper so that you don't have to manually map your DTOs to entities, for example. Okay. Abstract. Another cool feature we introduced is aspect-oriented programming. So whenever you do an HTTP call against one of our APIs, we have a common log, a log method or log string that gets into our log file, which just includes something like, okay, which method was called, which class was called, what parameters did we have, how long did it take, and I also add a proper correlation ID. So whoever thinks, okay, what's a correlation ID now? That's just to get together multiple method calls with the same ID so that I know, okay, I don't know, he was hitting my API with this call. I know because the name was in the request. And then I can check, okay, what correlation ID did this request have? And then I just look up this ID, and then I can exactly filter what other methods were called to fulfill or maybe to trigger the exception we had. Okay. I think I have to skip that. Okay. Yeah, I think that's it for today. What I want to mention is, at the moment, I said we are 32 people. So we would be happy to find new people down here in Pristina. So if you want to apply, or if you're interested in what I just told you, I mean, this was a very short introduction, to be honest. There would be much more to talk about. Then please apply at jobs@openresearch.com. And if you were wondering what these pictures on the right side were, these were just pictures of our office in Pristina. It's not stock pictures somewhere stolen from the internet. Okay, thank you very much.